I don't have a PowerPoint. I thought I would just talk with you all this morning and share a little bit about what's going on with the U.S. Forest Service and where we are with our soil moisture monitoring program in the past year. And you all know it's been a tough road the last few months, and we've lost a lot of scientists. We've had some chaos at our national forests, and we're all still working together to try to figure out what is it amongst our collaboration within our own agency that we can still continue to do to focus on soil moisture, because we know that soil moisture is very important for forest management, has tremendous applications with timber harvesting and trafficability, range management, wildfire science, prescribed fire science, recreation and timing and use. We also are able to use soil moisture at multiple scales. We can use it, we can take information at a very broad national scale using the National Drought Monitor, and also using it in the context of forest drought. We have a new product coming out called 4Dry that was developed by the National Drought Mitigation Center, and several of the U.S. forest soil scientists are on that pending publication and have engaged in that model. So now we're moving into the realm of predicting droughts in forests and what that might look across the country. We also have we're also looking at soil moisture at landscape levels as we look at climate change, adaptation strategies. We still have a tiny bit of work going on that we've been wrapping up. And as we look at vulnerability and what happens related to timber management as soils become drier. Will we see the same species come back after we harvest? And particularly in the concept of post-fire, what species should we be planting back in landscapes that actually won't regenerate on their own? And that is some of the difference between the East and the West. So the Forest Service is still concerned about those aspects of reforestation. And we're still concerned about our in situ monitoring on our national forests, looking at forest soil disturbance monitoring, like how wet is too wet, and what are mitigations and design criteria to conduct timber harvest operations. We have a mandate now, a memo that says we must increase our timber production. So how are we going to do that sustainably? We're going to need to use more tools. We're going to need to understand the conditions on the landscape even more than we do now. And soil moisture will be one of those variables that we're going to want to monitor to be able to have sustainable forest management and timber operations. And also it's tied to soil productivity and knowing what our site productivity is for timber management. So still a big part of what we're doing in our agency and what our focus, we're just down in capacity. And you all are able to read, USDA and our numbered losses from our resignation. So, but we're evaluating that, and we're still here, and we're very happy to be here this week. And we're really excited to host your field trip for you on Thursday. That's field trip option A that takes you out to look at some of the post-fire restoration projects and talk a little bit about that. And you'll also see one of our RAWS sites, our remote automated weather stations. That's kind of in the realm of what's to know, tell, and scan. This is connected to our National Fire Danger Rating System, and it's a national network of 2,200 stations across the country that are maintained and operated, that have real-time data that goes through the GOES-2 satellite, and you can look at that online at any time. The periods of records for some of these sites are very long. Soil moisture, though, is something people in the past have wanted to add to these stations. It's not standardized. But we've been trying our best through a grassroots effort on a state-by-state basis to look at adding soil moisture to these stations, and then trying to make that a tool that comes online. And right now it's working on a state-by-state basis. We've had some really great successes in Georgia, some successes in Missouri, and some of those folks that are overseeing those successes are here, but it's hit or miss. We run into all kinds of logistical errors and challenges with clearance and trying to make sure that we find the right people to help us get the sensors installed and get them operating to the data loggers. So it's challenging, and we've lost a lot of capacity in our fire, aviation, and management program. So you know, we're doing it, but we're still we're moving ahead, but slower than we'd like to. And funding is always an issue. We don't have a primary source of funding for that effort, but we're still committed to doing it. One of the bigger efforts that I oversee is a collaboration between the National Forest Service and the Natural Resource Conservation Service. And this project is a multi-million-dollar effort that looks at monitoring soil moisture engaged watersheds using digital soil survey and dynamic soil properties on experimental forests that are owned by the National Forest System and operated by the Research and Development branch of our agency. And we've got 7 different projects going on all the way from Alaska to New Hampshire to South Carolina, West Virginia, New Mexico, up at Marcel Experimental Forest in Minnesota. And I think two other sites have joined us. And we're looking to venture into the urban environment if we can find additional funding. That project focuses on multiple aspects of soil moisture monitoring on the landscape and modeling, data collection, QA/QC, developing an application using the Shiny app to be able to look at that data, monitor QA/QC, and then have it displayed outwards for use. Storing data, you know, where do we store this data, and and being able to host it. We have an ORISE fellow, Emily Pache, who oversees this for us. So in that realm, those 7 different projects have different resource management focuses of like why they are monitoring soil moisture and what's the goal of getting that. So that's a very exciting project that still has several years of life left to it. It too, is running into complications with grants and agreements and making sure the money gets out and making sure the students are able to work. But through persistence and through diligence, and we are able to, we're still on it and we're still working on it. We're committed because we think this is really important to bring the science of soil moisture and forest soils to the table so we can have a holistic conversation from the top of the watershed to the bottom of the watershed, and helping agricultural applications understand that what is going on in agricultural fields and landscapes and rangeland landscapes is connected to the watershed up above them, where most often it's forested. And also the threat of wildfire. What happens when wildfire goes through that watershed, and how does it affect downstream uses with soil moisture tied to reservoir management and irrigation management? Then there's the flip side in the east. What happens when you have flooding, you have hurricanes, and knowing something about soil moisture is very informative with that. And the Forest Service is very interested in helping to try to provide that information, because a lot of our landscapes in the mid-Atlantic region, particularly through Kentucky, Virginia, West Virginia, Tennessee, heavily forested. So when we get rain, and we get a lot of rain, understanding what's going on with soil moisture, that data can be tied into models to then again help with prediction. And knowing the soil survey aspects, being able to understand your soils on the landscape, these are all things that both NRCS and the US Forest Service are interested in building out tools for use. And we think that our farmers would very much care about this. We think our private citizens and those that live in the wildland urban interface would care about this, and our forest managers would care about this. So we continue on with those efforts. We also have some very well-established projects on national forests that we're still committed to in Kentucky on the Daniel Boone National Forest. If you've been to past meetings, you've heard Claudia Cotton and Matt Cherry talk about this in collaboration with the Western Climate Center. That project now has 2 mesonets and a micro mesonet, and those soil moisture sensors are actually under canopy. I think it's one of the few places where at that scale, at that micro scale and the landscape scale, that the sensors are under tree canopy. And there's a lot of challenges. I mean, we have special sessions talking about animals, and that's all we talk about. Like, how do you do this? How do you prevent bears from disturbing them, wolves from digging things, animals chewing through cords, all kinds of stuff. Another area where national forests are doing well with local applied soil moisture and on-site monitoring for real-time go, no-go scenarios is in our Region 9. That's in our north, that's in the New England area, all the way over to the Lake States, and then down into the Mid-Atlantic, where soil scientists are using soil moisture sensors, being able to say, no, these units are too wet to harvest, you know, and developing, you know, correlation curves. Like looking at what soil moisture data comes in, and then going out in the field and developing the correlation curve to go along with that. Then we have desires, then we also have had projects in the Southwest, but we've lost a lot of capacity there. We've lost most of our soil scientists to resignation. So we've got some projects on hold. Likewise, up in the Pacific Northwest, we've got soil scientists there that want to have soil moisture measurements related to assist in fire modeling. And over in Region 1 in Montana. And we're in a pause right now on that until we figure out how our agency is going to restructure, what will we look like, and where will our capacity be, and how will we become very efficient at getting that information out. So my hope is to be around in the near future to be able to continue to oversee this. I also got reassigned recently, and I am now in fire science research. So at 53, I'm learning fire physics for the first time. And it's great. And I'm doing project management. But the great news is what I found in that fire community, that there was a home for soil moisture and a great interest. So that's just, to me, just a big opportunity. Instead of saying, oh no, what's going to happen? Is this all going to go away? Are my relationships going to go away? That is absolutely anything. It's the opposite. My relationships are going to grow. My opportunity is going to grow, and my ability to get more people to want to invest in this science in this community. So that's the next step for me. And what I hope to encourage the U.S. Forest Service to engage with is thinking bigger, broader, and becoming more integrated in the way that we talk about soil moisture and getting those that care and want to understand about it. So not all of us, we had a limited number on the field trip for Thursday, so I won't be able to see all of you, but those of you that do get to attend, I'm excited to be able to show you some things in the landscape about applications of soil moisture with post-fire restoration, you know, municipal watersheds, why people care, and you'll get to hear from the collaborators and partners that are working with the U.S. Forest Service on the Arapahoe Roosevelt National Forest. So that's my hope. And we'll give you, on Wednesday, we'll tell you a little bit about field trip logistics and so forth. So with that, Mike, I give it back to you, and I'm around all week. Please introduce yourself. Come talk to me about projects, and we'll see if we can make something work together in the future.